Question 4, Part 8, to define the specific latent heat of fusion of a substance. There is only one formula for calculating or defining the specific latent heat. So this formula is latent heat symbolized by L equals to the Q for the thermal energy, okay, divided by the mass. I'm advising my students to use this formula for defining the specific latent heat. So it's an energy, it depends on two terminologies. So it's a derived scientific terminology from these two symbols or two physical quantities, the Q, which is thermal energy, and the mass. And keep in your mind, this one is not the specific heat capacity. So in the specific latent heat, it doesn't depend on the change in the temperature. So there is no delta T. So the latent heat you can get without having change in temperature. The only change the state itself or the matter itself. State of the matter, so this thermal energy required, so this one to complete your definition, to change what, as I said, they change the state of specific amount, which is 1 kilogram. This one I'm using the denominator now, which is the mass. So the SI unit, which is 1 kilogram. And fusion, it means that you change it from solid state. If you want to say pure solid, no problem for this, to pure liquid or liquid state. And this one happened, you remember this one, it means a change of a state from one form to another one. It means that happened at constant temperature, which is 0 degrees Celsius. And this one, it means that melting point. Okay, so this is the correct definition now. We get 2 marks for showing the thermal energy, this one which is needed to change the state of 1 kilogram of solid into liquid. And this one happened at a specific constant temperature. It means there's no change in temperature. For part B, small pieces of ice at 0 degrees Celsius, which is the melting point, are added to 0.35 kilogram of water. The initial temperature of the water is 24.5 degrees Celsius. So this is the TI. The temperature of the water decreases to 0 degrees Celsius. Yes, this is logically because you already added small pieces of ice. So we're trying to decrease the temperature of this water. And please try to focus on the common sentences. The water loses the 35,000 joule of thermal energy as it cools down, and all of the ice added to the water melts. Okay, some students, they hurry up and they go through the question without reaching the highest level of understanding or the deep understanding which is going on in the question. So I'm advising you, if you did not get the concept from the first time, so please stop the video and read the question again and again, at least twice. So this water loses 35,000 joule of thermal energy. When it goes to as gaining energy already gained by the pieces of ice, which was at 0 degrees Celsius. And there is a change in its state now. So this heat energy is a latent heat and gained by the ice, and there is no increase in temperature for the ice to already melt. And once it melts, it means that there is, according to the conservation law of energy, the energy neither created nor destroyed, but convert from one form into another form. Yeah, this is according to the conservation. And one more point that this energy already lost by the water, it's not destroyed, it's already gained by the ice to change the ice into added water or water inside the same beaker or wherever. Then the specific latent heat of fusion, he gave us the 3.3 times 10 powered by 5 joule per kilogram. So we might use all of these numbers or values again. So I just draw your attention, this is 0.35 quickly, the kilogram for the mass, and 24.5, which is the initial temperature, the 0.1, which is the final, and the latent heat for the ice, this is the value, and the Q, which is the amount of energy lost. The examiner is asking to calculate the part I, the specific heat capacity of water. One formula linking the specific latent heat and the mass and change in temperature. So the CW for the specific latent heat capacity, Q equals mc delta T. So we have to rearrange the equation. C equals Q divided by M times delta T, the change in temperature. The Q, which is, we have only one value of the energy, this is lost by the water, 35,000, divided by the mass, which is 0.35 times the change in temperature, which is 24.5 minus 0, or 0 minus 24.5 is not big issue. So the specific heat capacity, it's a value. It's 4,100 unit. This is the big issue. Students sometimes they forget the unit. Okay, do not be panic at all. The Q, which is energy, is measured in joule. So write joule and divided by, means slash, the mass, which is kilogram, and times Celsius, the degree Celsius. And please do not forget to make a degree Celsius like this. This question has 2 marks. 1 mark for the clear substitution with the correct one, and the final answer with the unit. In BII, the mass of ice added to the water. Okay, you remember there is only one formula for calculating the latent heat we didn't use in the previous one. Okay, so we have M, the mass of the ice. I'm sorry, this is unknown, and the latent heat is already given in the previous section. And the E, we have to think about this. You remember that I said in the previous section, stop the video and try to read again and again to understand which is going on in the question. The water lost 35,000 joule in the previous section. So, okay, I think this is the energy gained by the ice to change the state from solid to become liquid, or from pure ice to become pure water. So there's only one way to get the mass now. So we rearrange the equation, M equal E over L. The E, which is the 35,000, divided by 35,000 divided by 3.3 times 10 powered by 5. This is the latent heat. Okay, finally give us 0.11, and do not forget to write the correct unit, which is the kilogram SI unit. 1 mark here for rearranging the equation, and 1 mark for the correct substitution and using this energy, remember this, and 0.11 with the unit.